So today we're going to do solving systems of linear equations by elimination. So we've already done the graphing, we've already done the substitution method, and now I'm going to show you the elimination method. Okay, well, what elimination means is getting rid of something. So we are going to get rid of either the x term or the y term. Or if it was z, we get rid of the z term, but all of the questions I'm going to give you are going to have an x and a y in it. Okay, so let's just say, and we're going to just start at this point, let's just say I asked you if this was our first linear equation and this was our second linear equation. I said, add these two up. Well, what would you get? Well, 2x plus 2x is going to give me 4x. 3y plus 5y is going to give me 8y. And 9 plus 11 is going to give me 20. We did not do, it's great that we could add them together, and that's what we got. But we did not get rid of either an x variable or a y variable, okay? So what we're trying to do anytime we are doing elimination is we're trying to make zero pairs. So remember, like, if you had -2, how would I make that a 0? Well, I would add its opposite, which would be 2, and I would get 0. I'm trying to do the same thing here, okay? So I'm trying to get rid of something by using its opposite to make a 0 pair, right? So if we take the same equation, so this one time we added them together, but if I take the same equation and I subtract them, watch what happens. Exact same equation, I'm going to subtract them. Now, remember when you subtract something, basically the negative sign distributes into all of the other things, or you can think of it as 2x subtract 2x and 3y subtract 5y, okay? So either way, however you think of it, but if I'm looking at this question here, and I say now instead of adding them, like we did in the previous example, we're going to now subtract them. So if I take 2x minus 2x, I get 0x, because 2 minus 2 is 0. If I go 3 subtract 5, I'm going to get a minus 2y. And then 9 minus 11 is going to give me -2. Now, really, I have eliminated the x term because 0x you don't actually write. So I'm left with -2y equals -2, which what I've done is I have eliminated, which is what we want to do, one of the variables. Okay, so that just shows you either you can add, depending, like if this was a -2 and I added this, then it would have worked out because 2 plus a -2 would give me 0, and I would have gotten I would have gotten rid of the x term. I would have eliminated the x term, which is what we want to do. It can be the x term or the y term that you want to eliminate. Okay, well, what does this mean? What purpose does this have? Well, let's do another example here, and I'll show you what happens once we fully eliminate something. So if I'm looking at this equation right here, I see that I have a -2 and a +2. So if you have something where it's negative and positive, if I took a -2 and I added 2 to it, that's essentially what this is. Well, what happens? I get a 0. So I would get rid of this y term, which is what I want to do. Or it could be an x term, but in this case, because these were already lined up, I'm going to use that. So what did I do to this? Well, I didn't subtract like I did in that previous example. I added. Okay, so now I've got 3x plus 1x, and that's going to give me 4x. -2 plus a +2 is going to give me 0, so I'm not going to write anything down. And that equals 12 plus 8, and that's going to give me 20. Now from here, if I say solve for x, well, I've got 4x equals 20, divide each by 4, and you're left with x equals 5. What does that tell me? Well, that tells me my x coordinate, like just like when we were doing the graphing and when we were doing the substitution, for my solution, the x coordinate is a 5. But I need to figure out what my y value is. Well, in order to figure out my y value, I can just plug in my x to either one of these equations. It doesn't matter which one. I usually pick the easiest one. So in this case, this guy just has an x instead of having to multiply it by 3. So I'm going to take that equation. And wherever x is, I'm going to plug in 5. So I get 5 plus 2y equals 8. Now, over here, we have 5. So I want to bring him to the other side of the wall. So he's going to have to become a negative 5. And then I'm left with 2y is equal to 8 minus 5, which is 3. And then I have to get y by itself, so divide by 2 and divide by 2. And I get y is equal to 3 over 2. Is it okay that it's a fraction? Of course it is. So what that says then is my y value then is 3 over 2. So my ordered pair, my solution to this would be 5 for my x term and 3 over 2 for my y term. And if you really needed to know where that was, 2 divided into 3, it would go 1.5 times. So it's 1.5 is if you're more of a decimal kind of person. Okay. Now to check it, you can check it. Well, I would suggest checking it into both of the equations. Okay. So our first equation was 3x minus 2y equals 12. And our second equation was x plus 2y equals 8. And we have to check. And we're checking, remember, 5 and 3 over 2. So 5 is my x term and 3 over 2 is my y term. So I would go 3 and times 5, because that's what I figured out x was, minus 2. And our y was 3 over 2. And that equals 12. And then if I multiply this, I'm going to get 5 times 3, which is 15. Again, you can put this over 1 if you want. So I would get negative 6 over 2. Or if you prefer, you can cross reduce and say 2 goes into 2 once and 2 goes into 2 once, and then you get just 3, which is what this is going to give us. But we'll just leave it like this. That equals 12. And we're going to say 15 minus 6 divided by 2 is 3 equals 12. So we ended up getting 12 is equal to 12. And that's a true statement. So we know that it works for that equation. Let's do the same thing for this one. X is 5 plus 2 times y, and y in this case again is 3 over 2, and that equals 8. And so we're going to get 5 plus, well, this is again 2 over 1 if you want to think of it that way. So we get 6 over 2 equals 8, and 5 plus 6 divided by 2 is 3 equals 8, and we get 8 equals 8, which again works out. So we know that this solution here is 100% correct. So our solution is 5 and 3 over 2. Okay, so if you were doing this graphically, you know that the two lines would cross at 5 and 3 over 2. So that would be 1, 2, 3, 4, 5, and 1.5. There's 2, so like right about here is where the two lines would cross. And if you were doing it with substitution, you would get the same answer as well. Okay. Okay, so the important thing, or the main note here, is that you always want to either add or subtract the equations together in order to get rid of or eliminate either the x term or the y term. And for all of them, you should be able to do that, whether it's the x or the y, depending on what equation you're given. Sometimes, though, before you add or subtract, you're going to have to multiply to get them the same. And what I mean by that is this equation here. And we kind of did, we took the first step in doing this when we were doing the substitution method, okay, where we have to times the whole equation by a number. We're going to do the same thing here. So if you look at this equation, you will see that in order to get rid of the x term, I would have to get these two to be the same number. So I'd have to times this whole equation by 5 to get 15, and this whole equation here by 3 to get 15. And sometimes you will have to do that. I usually look for one where I just have to multiply one of the equations. And so if I look at the y term, he's 8y. can I make this -4 look like an 8? And the answer is yes, right? And even I can leave it as a -8 because then I will just add the two equations together and away we will go. So what I want to do is I want to get this 4 to look like an 8. And in order to do that, I have to times this by 2, which means I really have to times the whole equation by 2. So you can either write it like that, or you can go like this and say times by 2, however you want to do it. Or you could say like equation 1, I have to times it by 2, and that will give me, well, if I take 5x times 2, I'm going to get 10x. If I take -4 times 2, I'm going to get -8y. And then I'm going to take -22 times 2, and I'm going to get equals -44. So that is my new equation. And then this equation I didn't do anything to, so I'm just going to write that right below. And then what you can see is these two here, they're the same value except opposite, so they're going to give you a 0 pair, right? So really basically what I'm doing is going -8 plus 8, and I get 0. So what I'm going to do, I have to do that for the whole thing, and I'm going to say 10x minus 3, or sorry, 10x plus 3x is going to give me 13x. The y's are going to disappear because -8 plus 8. And over here, we're going to get -44 plus 18. And that should give me -26. And then I have to divide by 13. Divide by 13. And we get x is equal to -2. Okay? So from there, now what we do is we've got x is -2. You choose one of these equations, the original equations, not the one we multiplied. So let's go back to the original equations. I'm going to pick this one this time. It doesn't matter which one you choose, but wherever I see x, I'm going to plug in -2 instead. So I'm going to say, okay, 3x plus 8y equals 18, and wherever I see x, I'm plugging in -2. So 3 times -2 plus 8y equals 18. And then I say 3 times -2, that's going to give me -6, plus 8y equals 18. And we have to get y by itself. So I want to bring this -6 over the equal sign, or add 6. That's what I'm doing over here. And I get 8y is equal to 24. Yeah, 24, sorry. And then I divide by 8. And I get, oopsies, I get y is equal to 3. Okay? So then, basically what my solution then is x is -2 and my y is 3. Okay? And now I want to go back and I want to just check those two answers. Oops. So I take my one equation, which is 5x minus, and you always take your original in your check. So 5x minus 4y, 5x minus 4y equals -22. And then my other equation is 3x plus 8y, 3x plus 8y equals, ooh, what is it, 18? Yes, 18. And I plug in my x and y values. And so my x is -2 and my y is +3. So I say, okay, 5 times -2 minus 4 times 3 equals -22. And I say this is going to give me 5 times -2 is going to give me -10. 4 times 3 is going to give me -12. And I get -22. And what is -10 minus 12? Well, that's -22 equals -22. So that one is correct. Then we're going to check it with the other guy too, just to make sure. So 3 times my x, which is -2, plus 8, my y is 3, equals 18. And we're going to get -6 plus 24 equals 18. And what is -6 plus 24? Well, that is indeed 18 is equal to 18. Okay. So let's try another one of those. And then we've got two exception ones again. Okay, so for this guy, our x's and our y's aren't. They don't match up. So can I just, if I times this by, can I make a 3 look like a 5? No. Can I make a 4 look like a 10? Yes, I can. So if I, oh no, I can't. A 4 can't look like a 10. Sorry. So for this one, you're actually going to have to multiply both of them. Okay? So if I look at, decide what you want to do. Do you want to get rid of your x's or do you want to get rid of your y's? It does not matter. I'm going to choose my y's to get rid of. Okay? So if I choose my y's to get rid of, I have to say, well, what can I make both a 4 and a 10 become by multiplying by a different number? And my answer is 20. I can make a 10 look like a 20 by timesing it by 2. And I can make a 4 look like a 20 by timesing it by 5. Okay? So that's what I'm going to do. I'm going to take this whole equation and I'm going to times him by 5. So then I'm going to get 25x plus 20y equals negative 140. I think that's what you get. Yes, negative 140. And then I'm going to, on the bottom, because I made this a 20, I got to make this a 20. So in order to do that, I have to times the whole thing by 2. And I'm going to get 6x plus 20y equals negative 13. So now I can eliminate that 20y. But I can eliminate that 20y not by adding, because if I go 20 plus 20, I'm going to get 40. So I have to subtract, and you have to remember that subtraction sign for each one of them. So I say 25 minus 6. Well, 25 minus 6 is going to give me 19x. 20 subtract 20 gets rid of it. That equals, now be careful here, because it's 140 subtract a negative 13. So what happens with these two minus signs? They become positive, and we get a negative 114. Okay, and then we got to get x by itself, so we're going to divide by 19, and we get x is equal to negative 6 when you divide 114 divided by 19. So x is negative 6. So then in order to find my y, I take one of these equations and I plug that guy in. I'm just going to pick the first one just because. I picked the second one last time. There we go. Wherever x is, I'm going to plug in negative 6. So 5 times negative 6 plus 4y equals negative 28. And I go 5 times negative 6 and I get negative 30 plus 4y equals negative 28. And then I have to get y by itself. So again, we got to move this negative 30 over here, or like add 30, same thing. And we get 4y is equal to positive 2. And then we have to divide by 4. And we get y is equal to 2 over 4, which can be reduced because 2 goes into both of those evenly and we get 1/2. So our y value is 1/2. So we have negative 6 and our y value is 1/2. Now if I go to check that again, we have to use our original equation. So 5x plus 4y. So check 5x plus 4y equals negative 28. And then the other equation is 3x plus 10y negative 13. We're going to plug these values in. So we're going to say 5 times negative 6 plus 4 times 1/2 equals negative 28. And we get negative 30 plus 4 divided by 4 times 1/2 is going to give you 2 equals negative 28. And we're going to get negative 28 equals negative 28. Then we go over here and we say, okay, from there now, well, how am I going to figure this out? Well, again, I'm going to plug in negative 6 for x. So 3 times negative 6 plus 10 times 1/2. Does that equal negative 13? 3 times negative 6 is going to give me negative 18. Plus 10 divided by, or 10 times 1/2 is going to give me 5. Does that equal negative 13? Well, negative 18 plus 5 is negative 13, and it does indeed equal negative 13, and we are correct. So this is our solution, that negative 6 and 1/2. Okay, now again, like every other one, there's exceptions. Well, not exceptions, but just where you're either going to have no solution or infinite solutions, right? So if I look at, oh, did I do that on the bottom? Interesting. Okay, well, let's try this one first. Number 3. Now, again, you can see y and y, right? So we don't, and we also have 2x and 2x. So it's totally your choice which one you want to go for. But remember, we can't just subtract them, or sorry, you can't just add them, because if I said 2x plus 2x, that's going to be 4x. And if I went negative y plus a negative y, that gives me negative 2y. So in this case, we are subtracting, and we get 2x minus 2x, which is going to give me 0x, so they go away. And then we get negative y, so think about this, negative y, subtract a negative y. Well, what happens? We get negative y plus y. Well, that gives me nothing, right? 0, it gives you nothing, 0. So we're left with 0 on this side equals 4 minus 3, which is 1. Well, does 0 ever equal 1? No, this is a false statement. And so if it's a false statement, you know that there is no solution. Just like the last question. Or not the last question, sorry, the substitution method. If something is false at the very end, you know darn well that there's no solution there. So this is a really easy one because there's not a lot of work you have to show. What if we try this one, number 4? And if I look at this one and I say, okay, I need to change one of these. So if I wanted to go change the 2 to look like a 4, I'd have to times this whole thing by 2 in order to make it a 4. So I'm going to have 4x, and then negative 4 times 2 is going to give me negative 8y, and that's going to give me equals 18. And down here, we get the same thing. Oops, that's an 18. Well, they're the exact same equation. So again, if they're the exact same equation, you know that it's the same line, so it's then infinite solutions. Because it's the exact same line. The equation is 100% the exact same. But let's say if I actually went ahead and tried to subtract these two. So I get 4x minus 4x. That gives me 0. 8y subtract a negative 8. So that would give me negative 8 subtract another negative 8. These would turn to a positive, and I'd be left with 0 over here. Well, what is 18 minus 18? 0. So again, you get 0 equals 0. Is this a true statement? Yes, it's true. Therefore, infinite solution. So when you get down to the bottom, if your variables totally disappear and you just get two numbers and the equation is true, like 0 equals 0, then you know it's an infinite number of solutions. If your answer is false, like 0 equals 1, then you know there's no solution. So those ones are easy ones because you know something's a little bit different, right? You're not going to get an x or a y value. Okay, so you will have any assignment based on this as well. And so hopefully these make some sense to you. There's always the 3 different ways you can solve the equations, which is the graphing way, the substitution way, and the elimination way, which we just did today.